Automation with NetGrew. I'm your host, and today we brought back Pedro Damasceno. Welcome back.
Hi, Adrian.
Super excited to have you back. We were talking
Great
about
to be
it for
back.
a while. I
Yeah,
know. I'm glad to hear. So, how have you been since the last episode that we've had here?
man, so much has happened during this time. The project has involving. I saw today we're on the 22nd. Next month, exactly on the 10th, 22nd, I'll get married. So
Wow!
yeah, a lot has been going on, and I mean,
Early
excited to show you.
congratulations! Early
Thank you,
congratulations
thank
on the
you.
marriage. Yeah.
Yeah, thank you, and excited to show you guys where this project is going to getting some maturity, flexibility. Yeah,
Did you get any more attention around the project following the live stream that we've done? Possibly, maybe, at least
yeah,
internally.
yeah. Some of the guys reached out to me to get some tips. We have the website, the Autonet Ops, currently only in Portuguese, but some people already reached out or want more content. My YouTube now, the Autonet Ops YouTube, now is fully in English, so I have been releasing some content in English, and we today I will open source parts of some codes that I have built around this tool, not only the agents, but around it. And I mean, now it's been implemented in production, and we're going to see how it's coming along.
All right. So, I mean, without further ado, right? I mean, I think we
Okay,
can
stage
jump
is
because
mine.
yeah, I think there's quite a bit of content that we want to cover, and let's see if we can wrap it up
Yeah.
today. If not, we'll bring you back for part three. So, let's
All
see.
right, all right, all right. So do you guys see the screen?
Yep.
All right. So basically, the idea of this tool is that it was supposed to be an aggregator. And I was building the AI agents around it, right? So came to me that building AI agents, it has a lot of similarities to building a proper intent-based network automation, right? Because I mean, follow me on this, see if you relate to this. We start our network automation journey by first trying to understand what is the impact of this. So we're going to run some scripts first to show commands to understand the network, right? So initially, we're going to run something like this. We're going to connect to a device, send a command, and see what's going to happen. And then we're going to start, okay, I'm going to add more and more devices, and eventually we're going to be able to, okay, now I feel confident. I see the how long it takes. The I gain confidence on my network automation, and then I start to create configurations in a very imperative way, right? We started with a smaller site, a contained environment, a secure environment, and then we start to create something very imperative, right? We really describe what we want to send to each part of the network. So like here, we're going to send this command to this bunch of devices. And then we start to abstract, right? So we're going now, what if I remove the configuration that I'm going to send, and then I'm going to put in a YAML file? So I start to create some abstractions, and eventually we end up in that place that we are just creating something that is not vendor specific, like a YAML that is vendor neutral, and our configuration is going to load and push to the devices. Follow me, because we're going to reach to the AI that's pretty similar to that. So we start creating this abstraction. Eventually, we want to give other people access to this. So we're going to put our information in a source of truth. We're going to create access to other people, create APIs that other teams can call it, right? So we follow this path with the network automation, and then eventually we have what's here, for example, our source of truth, that this one is Netbox, that tells us what is our inventory and how we're going to connect to it. So for example, here, all the devices, we have the manufacturer, the driver that is going to be used on that based on the platform, if we're going to, how we are going to reach out to it via SSH, via netconf, other protocols. But still, we have here on our source of truth how we're going to interact with our network. This is yet not our intent. Eventually, we want our network automation to be something that we build the intent, meaning what are our reachability intents, what are our routing intents, security intents, and then, for example, I'm bringing here another platform that's called InfraHub, kind of the same idea that you have your inventory, but you have the flexibility of creating your own model. Then we're going to create something like here, my intent. I'm going to write my routing contracts, my customer C2 provider edge. I'm going to allow this bunch of routes. My reliability, oh man, I cannot say it properly. My reliability contract. Every router on the edge must have at least 2 connections. So you create this, and this is my intent, and this is going to convert to my configuration, maybe my observability. Once I tell that a device has capability of GNMI, or I remove that, this should not only reflect on the configuration of the device, but also on my monitoring. What is my observability intent? How much do I accept until it becomes an alarm or how can I say? Something that offends my network, that we have to trigger something. This is what, once I build these contracts, is what will give my automation the proper way of going there and translating, creating a plan and pushing to the devices. And this would become something like this. Let me show you. For example, I was experimenting with the AI, with the MCP. I am create, for example, a proposed change that I'm doing some updates, and I'm changing the data here, changing the platform. Oh, sorry, come back. For example, changing the platform capabilities. I'm removing the GNMI, my routing contract. I am changing the prefixes that are allowed, and this is going to change the artifacts that are going to be sent to the device. So now my observability, I'm not going to expect GNMI anymore. We're going to monitor via SNMP. On my device configuration, we are changing what we allow on the prefix, and this will reach out to our network automation in a maturity level. And this will also be super important when we bring AI to the mix, because I want my AI to reason against something, not only the configuration, because the configuration is, let's say, it's how we materialize our intention. This is what we think we must configure to reach that intention, but it's not the intention itself. So let's go back to the lab that we're proposing today. This tool, I am using it to keep my inventory. Like, this is a snapshot of my network, and this is also in production. So I have, for example, around 2,000 devices that are under my team's management. So what I see here is what is my responsibility. The tool is tenant aware, so each one will have access to only their devices that are under their management. So here we see we have the provider edge, our customer C1, the core, customer C2, and something is missing. How do I maintain this updated? I can see here, for example, that this is discovered based on my source of truth. So for me to discover, it has to be on my site, on my network source of truth. So we do that. We would need to import and to keep this source of truth updated and converging with my network. We know that every day we have change requests. People are changing IP, changing descriptions, doing configuration changes, right? And keeping this updated is important, and it's very difficult. We often have drifts, right? Our intent here drifts from the reality. So we're going to use AI to help us maintain this, and we're going to use, like in the network automation evolving. Let's start with something simple. Let me use AI to help me maintain, to see if everything converges, to create tests, until I tell it, okay, let's start touching something. And then when we touch, it's not like how we're using Claude Code. We're not using it only, okay, let the LLM think or touch whatever it wants. We have to follow a strict path. We need to check if there are tickets, if we have to build a plan, we have to check if we are on the window maintenance that is approved. So we're going to see how we're going to achieve that. All right, so first things first, we need to import this device here to our netbox. I'm going to do that by, we can see here, for example, we have a ghost guy. This is found by the LLDP neighborship.
Mm-hmm.
And once we built the topology, this is our layer 1 topology. We have here the OSPF. You see that there is a guy here that we have an adjacency, that this is 10.25502, that we don't know about, because this guy is not in our source of truth, but we have an adjacency with him. And also on the BGP, I have a neighbor with this guy, and this guy has a neighbor with him. These two are basically the same router on different interfaces. So we're going to add this body here. We can just find, let me query.
So it shows that it's discovered, but it's not in the inventory yet. So by adding it in the source of truth, that will be also discovered, right?
Yeah, I mean, when you're in production, if I find this ghost devices, you're going to see a lot of stuff that is not yours to maintain, servers, firewalls, or load balancers, what so on. But the idea is that this helps the guys that are using this tool, like, okay, I already see something, me that knows the network, this guy is ours, and we should keep him in the source of truth. So I'm going to either query, or we can find this device if we look for it. We have access to all the LLDP that was collected for all devices, and we're going to import this. So we're going to adopt this device. The idea is that, let me just change here the name to be EMEA, and we're going to select that it's in our side. This is an Arista, this is our PE router, and this is 172.20.20.12. This is because I'm running on Container Lab, so sometimes here. Okay, so it's still not here. What it did, it added this guy to my netbox.
Yeah.
The only thing that it did, it only added the minimum that I have to reach out to this device. So only the management interface with an IP. Now I can reach out to him. The idea of this is that I have a script, and this is going to be open sourced, that I call, where's the name of him? Network to netbox. I'm going to change this to network to SOT, because I'm bringing more, not only netbox, InfraHub, and Autobot also. But the idea, you have here an Ansible discovery and a Nornir discovery. You can either use it in two ways. If you already have your inventory somewhere else, in a spreadsheet, or I don't know, in another tool, and you already have something you want to bring, you're going to put in your inventory here, like in Ansible, or create your inventory, put it here. We're going to discover these devices and bring them to netbox. Once they are there, okay, I just want to maintain this device. So we're going to use Python 3. Let's just do a help here. And this runs basically every day, or once someone wants to import or to make sure if a device is ready or synced, this script tries to sync the device, what it has on the device, from netbox. So the idea is that, what did I miss? Oh, of course, the name of the script, right? This code.
Can you zoom in a couple of times, Pedro, please? Just
yeah. Let me do the following. Yeah, let me first remove this. Better?
Yes, that's better.
Yeah.
Thank
okay.
you.
So what we have here, the discovery and a bunch of options, arguments, right? We can change the config, the settings, discover only a site, only a device by role, and we're going to use here, we're going to discover from netbox. So we're not bringing anything into it. We're doing from it and keeping it adjusted. So we're going to use, let me go back. The discovery from netbox, we're going to filter the site to the AutoNetOps intent-based networking, right? And this usually runs in a pipeline either every day or on request. It fires, discovers the device. It uses Nornir in the backend.
Mm-hmm.
I mean, the Nornir one, the Ansible, goes with with Ansible, and then we try to discover based on, can be Napalm, NetMiko, Scrappily, whatsoever. And then, okay, we would now see this device here. It brought all the, just one thing, I have to delete this. It brought everything. And for example, if we do a change on one of the interface description, the next time it runs, it's going to bring here. One thing important, maybe you don't want, like people are changing here on the main branch, and you don't want things to be changed by default here on the main. Maybe you're going to overlap with someone else's work. So you can also specify what is the branch that you're going to discover to. So this way you can see, like, from one day to another, what would be changed. Same way that we showed here with InfraHub. Netbox has its own branching definition. That's the idea. All right. So now that we have that, we're going to run a rediscover, because then it's going to basically catch everything, all the information that it has, and an environment that I have tested with around 2,000 devices takes around 5 minutes, something like that. Okay, now we have it. Now we have the PE EMEA 02, and we are ready to start playing around with it. Whatever I see here, the AI sees. If I don't see, the AI doesn't have an idea. The AI will have the same access that my SOT has. If my device is not here, AI will not know how to reach it. It will not know the IP. If the IP is someone changed and I cannot reach it anymore, my discovery fails, the AI fails. So let's start from the beginning, right? The same way, as I said, let's start from something simple, and we're going to build it from there before we gain confidence on the AI. So one of the ways it can help us is to build our compliance. So it's going to help me build my automation. I don't want it just to be changing everything, because this doesn't scale. I want AI to bring me to that golden state of the intent-based networking, and AI is going to help me reach that. So first off, I'm going to start trying to build my my custom checks. All right, so we have here some built-in templates that I had created. And what we're going to do today, we're going to ask AI to build it for us. We can either build it ourselves, so we can go to the wizard, and it will start from scratch, importing a template, or creating a new check from the beginning, like, okay, what is the filter devices that we're going to target, the assertions, the schedule, the actions. If it fails, it goes to syslog, Jira, webhook, Slack. How do we have any alert? And this is what we're going to build. So first, sorry. Where's the yeah? Let's create a simple one, or eventually we can create some more others that are more complicated. Let me grab one here that should be simple enough, that I have separated. Ensure that SNMP community is configured on Cisco and the Arista devices. That is it.
Straightforward, we're going to, simple.
Yeah, simple. We can start, I have already created some more difficult. For example, check if the GNMI is enabled on the configuration and try to see if the port is open. For example, it will do many assertions, but the idea, at least here, is that it gives us this starting point, right? So you see that it created the first one, that it finished before. So it's going to run, for example, it proposes show running config, include SNMP server community, and it's going to see if we indeed have the community string set up. If it doesn't find, we have an alarm. Okay, yeah, this is good enough for me. Let's say add notification to Jira. Okay, so it's going to try the notification, adjusting, and let's see, adjusted. Now we have an action that's going to fire to Jira on failure. Okay, updated check with Jira integration. Okay, save it and test. Okay, it's also proposed for some next steps. Okay, let it save. Perfect, save the thing, just for us to have it. Okay, it goes to our approval. Saved, now we have it, and it's going to fire one test, because usually what I do once we are building, I want to test it before I really commit to it, because after it, it's going to start firing to Jira or to creating alerts, right? So we see here, it's going to run against these two devices, that the core is our Cisco and the PE is our Arista. You see that it didn't get all of the device. The PE02 is also Arista, but it's not here on the test because we're limiting to two devices on the test. Okay, so it's firing the test. We have a runner here that runs the test, and good to see. You see that one of the devices has the configuration and the other one doesn't. The Arista doesn't have the configuration for SNMP. So this would be something that I would like to fix and touch our configuration, right? So let's say eventually I'll start to create many templates, many different checks in my network. We can ask it to check against our source of truth to see if it matches on the device. And if we receive a trigger, one of our AI agents is going to create try to solve. It's not going to try to push, but it's going to build a plan to solve, right? So let's give it a try.
So what LLM were you using in here, Pedro, for this?
You can use whatever. Let me show you.
It's just like an API key, right? Basically loading it up.
Yeah. So on this one, I'm using here the this is my Anthropic, and here it's on OpenAI, right? So you see that I have been testing a little bit with OpenAI. Somewhere already spent 14 euros this month. Let's even see, and I'm using what is the model? The Sonnet 4.5 and the Haiku 4. Something for the agents. Right. Yeah. Mm-hmm. So, but I mean, I've been testing with different agents. Of course, you have reach different outcomes or performances. Maybe you get some speed, and I have also tested with local. But my problem is I only have CPU servers available for me, so it is painfully slow. Man, it's painfully slow. Even if I get a model that is not so dense, it's too slow.
And we're trying to run it locally with Ollama, or how?
Yeah. I mean, I tried with Ollama. Ollama is great if we are prototyping. What I've seen is that in production, usually when people ship to production, is not Ollama the framework of choice. You have some of them. I think I have deploying LLM on premise. You see, you have some VLLM, Llama CC, .C++, Ollama, and there are some differences with why would you choose one over the other. Ollama, it's great for prototyping because it just works, right? You install as a Docker, pull the image, ship it, and it works. So it is very good. We configure it here on the config AI. You see, you just change to OpenAI and adjust the model that you want, and there you go. So for example, here, if we change to OpenAI, I did put OpenAI because yesterday I was testing and I got an error 529 that their server was going through some high.
Oops! You broke their LLM.
Yeah, basically, yeah. They were said, oh, it's too much, so they were going through some high. What's the name?
Utilization or something.
Yeah, exactly. So I tested with OpenAI just to make sure. Okay, if something happens today, we're on the safe side and we can switch
between them easily. Yeah.
Yeah, so in the end, okay, let's fire a run. First of all, we don't have any ticket. One thing, sorry. Let me delete this run. I have to change something here. Okay, we have to check on here on the assertion. It's by default, I send to a project that is empty. So once we're testing, it doesn't bother me with creating tickets if I don't want them. Okay, so now we're ready. Let's run the test. It's going to fire the test, and we should see the result. Yeah, okay, so yeah, indeed, it failed for the PE EMEA 1. You see that now it tested for the PE EMEA 2. This one is good, and it created here the ticket. One thing important, what if we run again another ticket? So that's another thing that was created. No, we have a deduplication, so we can run again. It will add as a comment. Let's say, yeah, ran. And let me just update. Yeah. Come on.
And then from here, you have the option to approve, right? Okay, go and actually perform the SNMP config on the Arista.
Yeah, so by default, for example, we're going on a very slow steps, right? I don't want to trigger my AI yet. We can. I have tested like, okay, if my monitoring does fire an alarm, I want my AI agent to build the plan, attach to the ticket, find if there is a ticket, attach to it, and do at least my idea with the agent is that let's see it working. Let's grab here the AI agent. Let me just one thing first. Let me deactivate the ACI for a moment. Okay, then where is it? I have somewhere here the text already to, I don't know, SNMP, yeah. Okay, let's do the following. We're going to write here. Compliance, check the latest, let me increase for you. Check the latest compliance check for SNMP, verify the device that failed, build a plan to fix, and execute. Let's improve a little bit. SNMP.
And execute, wow, okay. Just the test plan.
Yeah, we'll see why that it will not execute in the end, even if I'm telling to. So community string should be auto netops and attach to Jira ticket. What is the name of the Jira? AI 157. AI 157. So the idea, once I started building this agent, remember from the last one, this is a LangGraph framework that is being used to create this agent. What is the advantage that we have, and why did I choose to go with LangGraph? It builds, and for example, what is the difference that it has from Claude Code or any other framework that you might choose? Here we are building, we are deciding the routing that it will take. So there is no way that my agent is going to hallucinate or decide to try to change things on my network, because it doesn't even have the capability to. It only has capability to call smaller agents that have the tools to gather information, but it will go through these steps. There is no way around this graph. So it is the advantage that in a highly regulated environment with a lot of compliance, you have very stages that are pre-built that you cannot get away with. But you, of course, if you didn't build the paths properly, you're going to pay that tax, right? It cannot go away from that. So here I built in stages. It's trying to classify the intent, gather the devices, decide, it's going to plan, and it's going to build the plan, just like a network automation. My orchestrator is going to build the plan, compile the plan, and then it's going to wait for someone to approve. And to the execution, it's not on the orchestrator, nor on my neither on my AI. Once it builds the plan, it's going to fire to the execution engine, and the execution engine is going to deal with running the plan. So the AI never runs anything. Even if I tell it to execute, it's just going to build the plan for me. We're going to approve, and then it fires. How does it look like? Okay, there it is. So you see, it created the plan for us. We're going to configure this SNMP server community AutoNetOps on P EMEA 01. The strategy, we're going to push all. So this is kind of the way that a plan is built. Not yet the maturity that I want, because what does a plan consist of? I need to know. I think we can open. This will also be open sourced. If we go here, I have another project that is called AutoNetOps IBM, right? So we have here like the planner, and this plan will compile how it's going to be executed. So my plan have, when it was created, the sources, the blast radius that we're going to achieve, the device that we're going to achieve, what is the stages that we're going to run, what are the steps in each stage, what are the policies evaluation, we have what is the strategy, a canary execution. A canary means one device first, or one tenant first, one site first, and then the next ones. This all is the plan. The plan is given to the execution, and it's going to translate. I don't care what protocol you guys are going to use. If this device supports netconf, go with it. If it supports a transaction, go with it. Does this change support a rollback? Do we have atomicity transaction, or are we going to run in a controller API environment? All of this is built in the plan. So my idea here is also that we build the plan. It's still raw. You see, it's small, but once we approve, it's going to now approve for the execution layer. Okay, so I am going to tell it, okay, execute. It fires to my execution layer. It takes the snapshots, attach everything to Jira, and go through a verification. It receives the feedback of the execution layer, and we should see now it here in Jira. You see that now move to in progress, now move to done. So what we'll see here on Jira is that all the snapshots before and after the plan, the V1, because maybe I don't agree with that plan. Maybe I want to change something, but I have all the logs for all the plans that it suggested. And this is how I'm building it for my alarms. It's only going to go until the plan. It's never going to fire the execution, but at least I can evaluate how well is it understanding or not, because here I have the human to clarify, but once it goes to, it fires in a headless mode, maybe how will we talk to it? Maybe it's going to just try to clarify itself. If it doesn't, I want the findings. It's going to try to triangulate. Maybe it doesn't push any config, but I want it to triangulate and even sometimes not solve my problem, but to constrain it. If I'm having an issue, for example, in one box, I don't want for you to change, it's not a configuration change. I want you to reroute the traffic, isolate that box, isolate that site, stop the problem. One of the engineers is going to come to execute. But just this triangulation is what gives me confidence to start saying, okay, let's fire the execution, especially because it is not the agent that is running. It's our execution layer. Again, I want to match it with my automation, because in a large environment, it's completely nonsense that I'm going, like in a lab, it works pretty well, but I don't want an AI to just go there and keep building, touching small stuff without a 4eyes approved. It will attach to our source of truth to know, okay, we cannot run this now. This is outside our policy. Where is it? For example, our change window. So it's outside the change window. It's not approved. This is going to be against our policy. So the AI will have access to all of this. How will we give access to all of this? Just to make sure it worked, let's fire again the run to see if it's solved. Yeah, perfect. Now we have something that we are fully compliant. So how are we going to give this agents a way to interact with other parts of our network? It's not flexible enough. You have some built-in agents, but how do I bring this to my company? The industry is kind of converging to the MCP solution. So we're going to expose MCP servers for us to connect. And how is this done? Let me close this. The topology kind of for this MCP environment is that we're going to have our host. In this case, is this application, right? So this server that we have on it, an MCP client, and we're going to spin up somewhere an MCP server that exposes what are the tools that we have available to connect to different devices. For example, ACI, Meraki, whatever you guys you have in your solution, right? So we're going to spin up now a server somewhere in the cloud. Like this server now is running in our data center somewhere in one of on Hetzner, and we're going to spin it up in one of our labs that uses GitHub code spaces. Where is it? So we're going to create a new code space. It's going to fire it up. We're going to create an MCP server, connect to the ACI environment. The ACI environment, what we have here, I just spin up a sandbox on Cisco DevNet. You just go to Cisco DevNet. They have a lot of environments that are available for you guys. This is very nice. If you don't have your own infrastructure for you to test, for you to explore, for you to understand solutions and lab it up. So what did I do? I came here to the ACI simulator. You have also the always on. It's great. So the only thing is this guy, for us to access, we need a VPN. So it is going to give us here the information for us to connect to the VPN. And then this server here that is being that is spinning up for us is going to have access to this ACI server, and then we're going to be able to connect to it, right? And then let's see how we're going to create. We're going to give our agent here access, these arms that are going to reach out to the ACI, and we're going to communicate with ACI and start creating. But again, even though I have my tools and everything that is the touches, I still want them to build a plan, and the execution layer is going to execute. I don't want the AI to execute anything. Again, it's only a plan. How are we going to tackle that? Where is it? Yeah, here. We have now here the Agent Studio. This is where I'm creating my MCP servers. And then from that, I'm creating a new agent and giving this agent, you are a specialist. So for example, I already created this ACI, created an identity. It's basically the skill. Okay, I'm telling it how to behave and the MCP server that is going to be attached to. So two things important here. Before, let's spin up this guy, finish. Where is it? Yeah, okay, so we have the environment up. Presentation, yeah. So first of all, we're going to install the VPN client. I don't have here the AnyConnect, so there is the script that you can run. I can open source it too for you to, in any server, is just download everything for you to connect via VPN. And we're going to prepare here. I cloned one of the Cisco Open MCP servers that they have available. I did had to fork it and do some tweaks because it only supported standard input-output and there was no authentication. So I just did some changes, small changes, and I'm pushing back. Hopefully they will accept it soon. And we're going to spin up this MCP server. So now what we have here the server and the .env. Where did I put the .env here? Yeah, we are going to create the information from this ACI. So here it is, the ACI APIC URL, username, and the token that we're going to use. This kind of matches what we have. Where is it?
It would be under your reservation, yeah, the active one.
Yeah. So, but the APIC goes with this IP, you see 10.10.10, and this environment here, if I try ping 10.10.2014, yeah, nothing happened. We don't have a VPN set up yet. So let's see if did it go. Yeah, so the only thing, AutoNet tops, VPN connect, yeah, domain, and this will be what they sent to you. Yeah. Please don't copy my password. And port, user, Pedro. Yeah, and then it's going to grab, ask for our password. There you go. Yeah, connected. So ping 10. Where is it? I did ping 10.10.2014. Yeah, so we have now connectivity to the ACI. To the tops, top, VPN set up. Yeah, no. Not set up, status. Yeah, okay, so it's up. The tunnel is up. We can already bring up this this server.
The MCP server, right? Yeah.
Yeah, so we just go to the CD scripts. Yeah, UV run Python 3 server. And there it is. And we already have this authentication token. So great. The MCP is up. One thing that we have to do is to open this port publicly. You see that it has the visibility private. Okay, now it's public. It is open. So we're going to connect, copy this address, and we're going to come here to the ACI, and we're going to MCP and save it. We're going to verify just to see if we have connectivity. And yeah, so we have 47 tools that are available for us. Again, so I want only some, I don't want it to, everything that's going to change our environment has to be gated. So here I'm attesting the tools. You see that it's going to list all the tools that we have available, and everything that has a get, I'm giving read access. What doesn't have, what changes, I'm adding here that it has write capability, so it's going to be gated. And I'm exploring how this could maybe be reversible or irreversible change. After we change, maybe we can roll back. So still, for now, I'm adding that this is irreversible. And some of them, I'm even telling like excluded. So even if you want, our agent is not going to be able to call this tool, because again, it goes through the execution layer, and this is going to gate and block any request that comes to this guy. Okay, so one thing we have just to, on our agent, come here, activate it, and approve that it writes. Okay, let's create a new run. Let's start from something simple again, just to check if we have really connectivity. One thing that is nice is that we're going to be able to see the requests reaching here, our MCP server, right? So list, let's call ACI. You see that now we have the ACI available for us, ACI. List the
tenants or something.
Tenants. Can be, yeah. List the tenants. And then let's ask it to create something that the last one, we built a plan that was only one configuration, right? So let's try to give it something that I want to see it creating the order that it would understand, okay, let's create a VRF inside here, and inside the VRF, a bridge domain, an EPG, and an application group. Let's see if it's going to understand, fire it up, and push everything. Okay, so no action needed. Here are the tenants available for us. Ah, sorry, I didn't show the, where was it? Come, yeah. Yeah, so you see that it made a request, it logged in, just called the tool to list the tenants, right? Okay, good. So create VRF auto netops and
bridge
domain auto netops underline BD and an EPG,
subnet or an EPG.
EPG auto netops underline EPG. And
in the application group or whatever it is.
Yeah, I'll add it in the heroes tenant EPG in the application group auto netops underline app in the heroes tenant. All right.
So that's an execution order, right? You have to figure out which one to create first.
Yeah. And then again, every time we fire this, it's going to go again on the gathering the agents, clarifying, resolving. What also is the an advantage of using the LangGraph here? My idea, it's not fully ready, but it saves the state that we currently are. So for example, if it asks for an approval, or if by any chance you restart your session, you can you have checkpoints, or that it saved the state that we currently are. So you just come back and you continue where you left off. So this is something that will really help us to maintain and to understand and to have traceability, to be to have determinism on the changes, because changing a network can cause a major accident when we are. It's not the same as developing that you, or just creating some helping me create the PowerPoint slides or anything like this, right? So let's see. You see that it's calling the tools, the ACI, context, and whatsoever. There it is. Great. So it proposed for us. It is going to follow in these steps. Create the VRF Autonet tops, then Autonet tops bridge domain inside the VRF, the application profile, and then the EPG. Okay, it seems good. Let's see. I don't even know how to evaluate this, right? So there it is. I'm approving. And my idea in the end is that it's going to be able to, remember this for now, it's, we're not changing. I'm not giving it a snapshot, but maybe we can give it a snapshot before, or a way to evaluate it against after. So this is the current moment that we are. Let's see if, did it create a ticket for us? Yeah, so it did create a ticket. Yeah, going to done. And yeah, there it is.
Nice.
All the plan, the execution log, and how can we evaluate this? Man. Okay, let me do the following. I'll bring up in my own machine, because then the problem is this server here it only has access to the MCP, right? I want to check if it worked without going to the MCP. So 1 second, we're going to come to my Docker compose up, right? So my machine, we're going to, where's the name? AnyConnect, right? AnyConnect. While it brings up, I don't remember the name, just to make sure.
And then to expose the MCP server externally, what are you using? Are you using ngrok or something like that, Pedro? Because I was seeing you pasting like an outside, like a public link.
Mm-hmm. Once you spin up this lab, you already have a public link attached to it. So GitHub Codespaces create for each environment that spin up a DNS name for it.
Okay,
And once you bring up a port, you just have to expose this port. So this is done in the backend for you. You just have to make it publicly available. And VPN. Our MCP now is going to lose access because here on this type of environment, you have only one connect attached to it. And okay, but we have here localhost, my own machine. And we are on the VPN connecting. Yeah, okay. 1 second, let me see if the okay.
So with the land graph, like you were saying, you're pretty much hard coding what the agent can do, right? It's like you only can do these things.
I'm hard coding. I'm hard coding the route that it's going to take. The LLM can in each node it is free to reason about, but it cannot decide what is the next path. The next path is that depends on your state. So come on, really? I don't know what I did. Admin, maybe I'm putting the wrong password. I don't know. Okay, we are going to do the following then. Let's validate, create another, expose the MCP another way. Let me think. Okay. Okay, we're going to
basically you're trying to show
I want
that
just to validate
using the MCP, it would still figure it out, right?
No, now I just want to make sure that it says it worked. I just want to make sure, did it work? Did it create everything? So that's the only part. But I mean, allegedly, it worked. I just wanted the validation because once we connect, let me show you this. No. Password. No. Once we connect, the idea is that we would be able to see it like this. For example, this is on the always on, so we have visibility. We would see here on the topology how the VRF that was created, that we have an EPG, that everything's connected, and that we have, so we would visually see that it created. Yeah, indeed, everything created and is associated, and something like this. Okay, we have a VRF, a bridge domain inside here, an EPG that maps to this, who is consuming what, and this would help me maintain. Because again, the idea of this tool is to aggregate everything and to give my network folks a way to quickly onboard or to quickly understand your network, because sometimes you're talking ACI and there is some guys that are not familiar with this world, and then you're like, okay, I already see I have a VLAN here, it's inside this VRF, we have an external connections that goes on these borders, we receive these routes, this is the static. So the idea would be that we have something to reason about and be able to have all this ecosystem working, understanding the topology. For example, this also brings the ACI to, let me just put only ports that are up, because ACI has so many ports that it kills once we sync to Netbox or anything else. But in the end, that's the idea. And then you see how it will step by step evolve and be controlled the way that we maintain our network. All right. So we should see now that we have now the ACI environment here. Also works like a charm when you are importing from a big environment. So now they are all accessible and they will be discovered on our, where is it? Oh man, agents, no, topology. It will be discovered on our next tasks, right? So we do the discovery. Now we have the topology together with the ACI because, let's say, this is now under my realm. But
so it will show the new VRF that you created also, right? And the new breeze domain and EPG.
No. Remember this. Let's see. It only sees the layer one topology. We didn't create any connection, any BGP. If we do can create BGP neighborships, then it's going to see. We see but we would see okay how the ACI environment is connecting to our. Do we have a layer 3 out or only a layer 2 extension? This gives you, like, anyone that looks okay. This, you see that this is within a site. I can just later check. Okay, we have this site connected to that one. How many BGP connections? For example, we have BGP connections going here or OSPF, and you're going to see a big amount of lines that it's really good for you to have an onboarding, right? And help you maintain your network. And also it comes with the AIs that are being developed. One thing that I would bring to this AI agents, I built the graph for this is the coordinator graph, and we have sub agents. So the coordinator graph is what gives me this security that nothing is going to be executed otherwise. But I also built my specialized agents with LangGraph, which I see that it's not the optimal way, because again, I'm limiting them when I want them to just figure it out. Okay, go grab. I don't want, if you have to recalculate or regather information, go from it. Since I'm doing it in LangGraph, if I didn't build that, it's not going to do it. So on the specialized agents, I'm kind of killing their
independence in a way.
Exactly. And then the part that I want that is good for the network part is that the flow of the changing or clarifying or opening a ticket, we're going to connect this to a service now or something else. This is always going to be here. This flow, these stages are going to be here. But my independent agents, they should be able to freely, okay, I need something else. Maybe, for example, I did try when I was exploring here the infra hub to try to ask it, okay, what would happen if I change my routing contract? If I remove this route, for example, I go and come here to the contract, and on the customer C2P, I remove one route. Who do I have to call? Which tenants is this going to affect?
Yeah.
And I mean, here they have something that is really great. That is this, where is it? Path traversal. So my agent can try to understand, create these dependencies. If I go to the contract for the routing contract, this guy, customer C2P, if I change him, what is the, let's say, location? The site location that is going to be affected. My AI agent would have access to this. But since I'm giving in my solution here some specific contracts, I'm limiting them, and then I'm killing the possibility for them to adapt. Okay, they tried once the MCP, now I sent with the wrong payload. Try again, failed. Okay, now then I am understanding, 2 tries, that's enough, stop. Yeah, but maybe it would achieve the result, So on the specialized agents, I'm going to shift. I'll probably go with another framework, but keep the coordinator using LangGraph. So that would be my idea. Yeah, actually, I think I did say everything that I wanted to.
We covered pretty much everything.
Okay,
with 5 minutes to go, that's not bad at all.
Yeah, so let's go. Maybe doubts or comments.
This is really cool, man. Yeah. So, what can you open source from this? You said a couple of times, like the population script that you have, right? That one in the beginning,
Yeah,
that was
yeah.
well,
The
putting discovery, the source of truth with NetBox, InfraHub. That was really cool.
Yeah,
Is that
I
something
have
that you think?
created also a template for MCP servers because, for example, I had some errors with this one that we have with ACI. So, for example, it didn't come with the authentication. Now, okay, I created an authentication that is going to use a JSON web token. What if we want basic authentication or OAuth? Another thing that happened, it logs into ACI, receives the token, eventually it expired and never tried again. So all my agents, they could never do anything anymore because they said, okay, we lost connection. ACI is not responding. I came here to see like, okay, my session was open long enough. So I'm open sourcing this template. You have all the how to bring it up, and then you can create your own tools. Because in the end, creating the tools is the easier part, but having already this bulk part that supports the type of HTTP, streamable HTTP that supports the different types of authentication. On this tool specifically, I have some students that are on AutoNet Ops that have I have asked to try to ship it. Some of them have, let's say, autonomy in their company to give it a try. So this is a way that I'm getting, okay, bugs, fixes. This already works pretty well, even with the snapshots, the AI agents. And I'm trying to see, okay, what are the specs that you need to run? It's missing something, for example, high availability. What if one of these boxes goes down? My agents, I want now them to be, so each tenant will have different agents, and once you fire an agent, it's going to be ephemeral. It's going to run. You have all the logs, everything here in your history that you can audit, but then they go down. So you can, I'm going to integrate it probably with Kubernetes. Currently, they are running just as Docker or Podman containers. And we have some horizontal scaling with Celery. So you can put each agent to be running like more than one agent at a time. So I'm not sure what I'll do with this yet. If you're interested, reach out for us here in AutoNet Ops. We have, usually there is a way for you to schedule a call with me. So you can just schedule this call. Come here, schedule a lot of people reached out, wanted to explore the platform or just talk about, give some inspiration or parts of the code. I am completely open to it. I'm not sure what I'm going to do with this, with it yet. And yeah, I want to give more flexibility. Now, for example, I only have the connectors to Jira and working on it. Now it has the logging with Splunk, with other types of products, and you would come here. And let's see.
I mean, this is it's a fantastic idea for a startup. You could build a whole startup around this, and you already have the
Yeah.
foundation
I'm
functionality
working
with it.
now. Yeah, I'm working now because in the end, I need again the agents to know intent and how we're going to model or create the terminology and the foundations for intent. So, for example, I'm exploring and to fit different environments, right? So, creating, for example, okay, I'll call. I only know what we call here, and I'm trying to do a translation and adjustments to be more open to the community, right? So contracts, what are contracts, the measurable outcomes, the policies, invariants, waivers. So I'm writing and exploring this because this is what, once we agree on that, the AI could really leverage and be exposed to different companies, and people would, even though building on their own specifics, but we're calling the same thing. The same way we do with all the other stuff, right? We're calling now orchestrator, execution layer, the observability, it's broken. We have the collector, the normalization, enrichment of data. I need this for intent. So I'm trying to explore how are we going to do that. I'm opening also this intent-based network. This is how I'm creating the plan. So how we are going to compile the plan and call the executor. So once we agree also on like, okay, this is based on that information, what are the best layers, blast radius, policy evaluation. This is just going to come here, understand, for example, on the devices, my capabilities. If we do have many devices that support netconf, we're going to use netconf. If it doesn't, we use SSH, all they support, we don't care. So the execution is really open source this for people to also understand how this is built, and maybe we can create something that moves together. I would even call it out, shout out, there is this blog called The Routing Intent from Leo Furtado. He writes about basically, I mean, a lot of inspiration came from his blogs that he talks about intent-based networking on hyperscalers. Maybe it's a great guy for you to call to come here. I would love to see him doing some presentation. And yeah, I would
The routing
recommend for
intent.
anyone. I think he charges like a coffee in the end of the month for you to read about, and it's so dense. So for anyone that's exploring network automation, I see this like, okay, yeah, this is the end goal. This is super valuable information, and I'm using a lot to give inspiration and guide me while building this project.
Fantastic, Pedro. Well, I think we covered most of what you wanted to show, right?
Yeah, I did.
Okay, so one last question, and thanks a bunch for the folks watching this. By the way, I see Forestiago there. He's been pretty much watching the whole episode. RVD, Go Pedro, Giuliano, Thaides. Thanks all for
Yeah, thank
watching.
you,
But then,
guys.
so you were showing the ACI AI agent, right? And creating a
Mhm.
new AI agent. It's as simple as just going and defining the skills, right? With text,
Yeah,
with what the agent can do. If you
yeah,
show
basically,
us,
yeah, yeah.
right?
You come.
And then
Let's
you
say,
point it
we're
to an
going to
MCP
create a new
server
one.
that it can use.
Yeah, or for example, the infra. Sorry, go ahead. Come again. I talked on top of you.
No. So I was saying just you. Let's show how you quickly
Okay,
create one.
I'll create like creating an MCP server. You just expose one,
Yep.
right? So the same way we did here, you verify. Okay, we have an MCP server. So
Yep.
you go to the Agent Studio. You're going to call what is the name, a description. You're going to create your identity. Sorry, it's because it needs a name. Yeah, it's going to create your identity. This is your instructions to like the skills, basically. Some tips here, how my coordinator might help him route to this guy. So, for example, if we go to the ACI or to the infra hub, so for example, if all the topics that are associated with the infra hub, source of truth, intent, pull request topology, policy, impact, if it sees IPAM, DSIM, it's going to, okay, give context, this agent might be the one related that I should call. Then you have the MCP servers, all the MCPs that you have available, you can say, okay, this agent has access to this MCP. Then it can call the tools that are gated by what the admin configured. Then you have access also, maybe if you want to give this agent access to this built-in tools that we have, you do a test drive just to see if you have connection. Once you do have connection, yeah, you just come, activate, enable it, and there you are. You have now your agent
It's that easy.
working.
Okay, just
Yeah.
wanted to make sure that I understood. So yeah, fantastic. And then as much as you can open source out of this would be really great for folks to play around, because this is really nice. And I agree with Thiago here. The way this tool visualizes the infrastructure is really nice. So it's much more than that, right? But just the visualization part, the discovery,
Yeah.
it's the integration with Jira, with your sources of truth, different ones. If you have Netbox or InfraHub or Nautoball, like you were saying.
Yeah. So for
It's
example,
just,
here, the good stuff is that you change environments really easy. For me, it really helps because, okay, I have a Netbox or InfraHub that is for my production. Then I have one for the staging, one for the lab. So you come here, you change, you see the different devices. The same way here that we have the fabric. You come here, create a new one. It connects to your fabric that goes to, I don't know, it's on Chicago. Another fabric is for another environment. You see quickly, much easier to navigate. You see, if you have tried to log in on this always on, it's painful slow. So here I can quickly see and start changing even with what we have here, the Terraform, to help me with environments. So people try to create their tools and play around with it.
Very
Yeah.
cool. Yep. We went a bit over time here, but thank you so much, Pedro, for coming on the stream. This has been fantastic. If
Thank you for having me.
at any point you want to come back, you're more than welcome. Let me know.
Thank you.
We'll fit you in the schedule. Folks, thank you all for watching.
Thank you,
We'll see
guys.
you all next week, same time, same hour, same day. We're bringing back also Suresh. So Suresh is coming back to talk about NetLab. We've started a NetLab episode with him, and also we didn't finish. So he's coming back to wrap that one up. So make sure you join us.
Suresh Vishna, something, right?
Suresh Vina, yeah. Yep.
Vina, yeah. Okay. Great
Yep.
blog also that he has, by the way.
Yes,
So,
fantastic blog also, like you, Pedro, right? Like the website that you have and the courses and the content is just, if you, it's fantastic in Portuguese, but now
no.
if you
I
can
completely use his. It's a reference for me also. It's a very nice blog that he has.
agreed, very, very
So,
cool.
guys, don't miss that.
Yep. So he's coming next week on Wednesday. Thank you all for watching. Again, thank you, Pedro, so much, and see you folks on the next one. Take care.
Thank you. Bye-bye.